Greetings, young minds. Welcome back to Reading Readiness Centers, your go-to place for exciting learning adventures. Today, buckle up as we embark on a thrilling journey deep into the realm of numbers. Ever felt overwhelmed by giant numbers or tiny decimals? Fear not, for scientific notation comes to the rescue. Scientific notation is a neat and quick way of writing very large numbers and very small numbers. A times 10 exponent b. Imagine a number made of different parts. Picture this. 2.3 times 10 caret 6. What does that even mean? Fear not. We are about to decode the secret language of numbers. A coefficient, a single digit between 1 and 10 followed by some decimal places. An exponent, a small number positive or negative that tells you how many times to move the decimal in the coefficient. The base. It's like the number system we are using. In scientific notation, the base is always 10. Think of it as a group of 10 friends hanging out together. Imagine the universe. Picture the vastness of space, with planets whizzing past and stars twinkling like diamonds. To describe distances this immense, we need numbers bigger than our brains can easily grasp. For example, the distance to the closest star is a whopping 40,208 billion kilometers. Writing that out is a pain, right? Enter scientific notation. Positive exponents. Let's take our star distance, 40,208 billion kilometers. In scientific notation, this becomes 4.0208 times 10 to the power of 12. Here, 4.0208 is our coefficient, and positive 12 is the exponent. It tells us to move the decimal in the coefficient 12 times to the right, adding zeros as needed. Negative exponents. What about tiny numbers like the mass of a hydrogen atom? 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 This becomes 1.67 times 10 to the power of negative 24. The decimal moves 24 times to the left, past all those zeros, making the tiny number much easier to handle. How do we transition from scientific notation to our standard form? If the exponent is positive, like here, shift the decimal to the right 6 times, resulting in 2,300,000. If it's negative, like this, decimal is moved 6 times to the left, yielding 0.00000023. Ready for some fun with scientific notation? Let's explore the world around us. How many times does your eye blink per year? 4. 2 times 10 to the power of 6 times per year. How many cell phones are in use today in the US? An estimated 2.5 times 10 to the power of 8. How wide is a plant cell in meters? Approximately 1.276 times 10 to the power of negative 5. Ordering numbers in scientific notation. Arranging numbers in scientific notation is like orchestrating a numerical symphony. Check the exponents, the key is the exponent. And, if they match, compare the coefficients. For instance, consider these numbers. Based on the exponents, we know that this is the smallest value. And then reorder the numbers, the smallest value exponent will come to the first. But, if the exponents are the same, compare the coefficients. The bigger the exponent, positive or negative, the bigger the number. If the exponents are the same, we compare the coefficients, the bigger the coefficient, the bigger the number. Like here, they both have 4 as their exponent, so we compare their coefficients. Since 2 less than 3.2, the correct order is this. Now, brace yourselves for a cosmic revelation. Proxima Centauri, the closest star to our own, the Sun, is just 40,208,000,000,000 kilometers away. Considering that a light year corresponds to a distance of 9 by 10 kilometers. That concludes our exhilarating exploration into the realm of scientific notation. If this numerical odyssey has sparked your curiosity, give us a colossal thumbs up, share the excitement with your friends, and don't forget to hit that subscribe button. Until our next adventure, keep unleashing your curiosity and learning with Reading Readiness Centers. Happy learning, young scholars!